I want to talk about area of a triangle. Normally we know that area is equal to 1/2 base times height if it's a right triangle. If we do not have a right triangle, we can use this formula in order to find the area of the triangle. Please note that when we're looking at our triangle, we have angle A, angle B, and angle C, and across from those angles are their corresponding sides. And notice that if we're going to use this formula, we need to know a side A, a side B, and the angle C. So in order for this to work, we need side, angle, side when it comes to our triangle. So let's try to find the area. So here's an example. Let's say we want to find the area of a triangle, and our triangle has side A, angle B, and angle C. We know that side A is 34 feet. We know that side C is 42 feet. And we know that our angle is 55 degrees and 10 minutes. So I know I wanted to do this problem on purpose is so that you can see that if we take a look at these apostrophes or whatever you want to call them, that they mean different things. So in this part right here, it means feet, whereas when we're talking about the angle, it means minutes. So in order to find this, if we want to find our area, and notice my letters are a little bit different, but that's okay. It's going to be 1/2 one of the sides times the other side times the sine of the angle that's in between them. So in this case, 55 degrees and 10 minutes. So from here, you can put all of this into your calculator written just like this, and that you will find your area is equal to 586, approximately, rounding to the nearest square foot. And remember, our units are going to be square feet. So let's try another example. This time, let us find the area of the triangle DOG, or dog in our case. The problem is that we know the two angles down here, that this is 24 degrees and that the other angle is 52 degrees, and the one in between them is 27 centimeters. So notice, in order to find the area, we need side, angle, side, and we have angle, side, angle. So we're going to have to figure out some other dimensions. Well, let's see if we can use the law of sines. For the law of sines, remember that I'm going to be using, in our case, little d over the sine of the angle d, and little o over the sine of big O, and little g over the sine of big G. So if we put in numbers, we don't know d. Remember, d is this side right here, and sine of d. We know little o is 27 centimeters, but we don't know the angle. And then little g we don't know, so we'll put little g, and then angle g is 52 degrees. Well, oh, wait a minute, I do know d, so let's make sure we change that. So angle d is 24 degrees. Well, remember what I said, if you know two angles, you actually know the third angle. Remember that 24 plus 52 plus the missing one, we'll call that O, have to equal to 180. So from here, we can find that angle O is 104 degrees. So I'm going to change that in my equation as well. So this is 104 degrees. So notice that we do have one of our fractions complete, which means we can use the law of sines. So I'm going to use this part right here so that I can calculate side D. So for here, you should be able to do the math. We could do our cross products of D times sine of 104 degrees is equal to 27 times sine of 24 degrees. And we can see that we can solve for D and find that D is equal to 27 sine of 24 degrees divided by sine of 104 degrees. And we can stick that into our calculator and find that side D is approximately 11.3 centimeters. So far what we found is this side right here, but notice now with that information we know side, angle, side, which is exactly what we needed in order to find the area. So let's continue finding the area. So if we want to find the area of our triangle, we need 1/2, one of the sides, 27, times the other side, 11.3, times sine of the angle between them, which is 52 degrees. Now, one of the things I do want to make sure I stress is that we can actually, instead of doing an approximation, we can actually store this value of 27 sine of 24 degrees over sine of 104 degrees. We can store it by hitting the stow key on your calculator, and then you can pick a letter. So we're going to pick it as D. I think all the letters you pick on your calculator have to be capital. So what does that mean to us? That means instead of putting this approximation, let's use this, store it, and then we can actually type in the letter D here so that we can find our area. Doing that, we're going to find that our area is approximately 120.4 centimeters squared. But notice that our significant digits, or if they tell us to round to the nearest whole, then it's going to be 120 centimeters squared. And for our last example, let's have two ranger stations that are on an east-west line. So I'm going to draw them over here. Here's our west one, here's our east one, and we do know that that's 110 miles apart. It says that a forest fire is located at a bearing of north 42 east, so about halfway in there, so we'll do 42 east. So it's somewhere over here on this line. And then at the same time, so that's from our western station, which we call point A. Over here we also have a bearing north 15 east from the eastern station B. Again, we're going to do north, and we're going to go 15 degrees. So this little one is 15 degrees. Our job is to the nearest 10 miles, how far is the fire from the western station? So we want to find, and here's our fire, here's our western station, so we want to find this length here. So again, this is an example about using law of sines, but we got to figure out what angles we know. So remember, over here from north to west, this is 90 degrees, so we can actually see that this angle here is 105 degrees. So this is what we have so far. I'm going to just redraw my triangle so you can see what we have. We have 105 here. We have 110 here. And we're looking for this guy right here. So we need some more information. In order to use law of sines, I need to know the angle as well as something opposite of it. So I need to find this angle here, so that way I can use the opposite side of it, which is the 110 that's over here. So let's see, I do know I have 42 degrees from here to here. From north to here is 42 degrees. And I know that this part over here, if I add it up to the 42 degrees, have to equal to 90, going from north to east. So I'm going to have 90 minus 42, and I'm going to find that that's 48 degrees. So that means this is 48 degrees. So if I know two angles, I know three angles. So if I want to find this last angle over here, I'm going to get my 105 and add my 48. And then I'm going to, which is 153. Then I'm going to subtract that from 180. And that's going to give me 27 degrees. So this angle over here is 27 degrees. Now, why did I do that? Because if I want to use the law of sines, I need to get one of the sides. I'm going to get my x, and I'm going to get sine of 105 degrees. Then I'm going to get the other side I have, which is 110 miles, and have sine of 27 degrees. And I can solve for x by multiplying both sides by sine of 105 degrees. So I'm going to have 110 sine of 105 degrees divided by sine of 27 degrees. And you can stick that into your calculator and find that's 234.04 miles. But remember, they want us to round to the nearest 10 miles, so approximately 230 miles. And that concludes this video.